Okay, so I'm going to bring this up because this is a lesson that George told me about. And I was like, this is gold. You've got to talk about this one. So here you go, George.
Yeah, look, thanks, Pauline. And I know I'm going to draw on a science concept here, but again, it's not the science that I'm demonstrating. We're talking about, strategies and activities. And I guess part of me concluding the first part of this session is just to show you a couple of strategies in terms of those we talked about at work. In the stage 4 science syllabus, the students need to know about the relative distances of the planets from the sun. And one thing I've seen, and again, can I say I've done this myself? When I started teaching 20 years ago, the first chapter in the textbook would talk about Earth and space. And there'd be a page on each planet. And it would give them certain numbers to do with these planets, whether it's the weight of the planet, whether it's the diameter, whether it's the circumference, whether the time it takes to go around the sun, or how far it is from the sun. And when you look at those numbers, you might remember yourself, we're talking about numbers that are 9, 10 digits. And straight away, leaving it to the students, they can actually get lost quite easily. So the first image was just showing them the relative order. Now, whether you do that as a video, whether they can see it on a PowerPoint, they need to see it. They also would hear these numbers. Now, again, whether these numbers might be in a video or whether me saying it. So, for example, Earth, 150 million kilometers from the sun. But saying it helps, seeing it, their relative position helps, but sometimes these large numbers are meaningful, particularly to students in Year 7, Year 8, when they don't have a concept or this understanding of what these large numbers mean. And it's all about how do we break it down. Now, that doesn't mean we don't show them the accurate or the correct numbers or show them the relative position. We start with that, but then we need to be mindful of those activities that will slowly unpack that for our kids. Now, in terms of this next one, there's an activity that I do using an A3 sheet of paper. And the A3 sheet of paper, the dimensions are 297 millimeters by 420. And what I do with my students is I cut up an A3 sheet of paper into strips. And each strip is the length of the A3 paper, but it might only be 1 to 2 centimeters thick. And I would hand every student in the room a strip of A3 paper. And because it's 42 centimeters, what I get them to do, I get them to mark 1 centimeter on one end and then to mark 1 centimeter from the other end. So now we're working on the middle 40 centimeters. And thanks for taking us back to this particular slide, Pauline, because the point I'm trying to make is with that A3 bit of paper that they've got, before they look at these numbers, what I say to them is do this, fold it in half. They all do it. Then I say fold it in half again. Give them 30 seconds to do that. Fold it in half again. And this is part of the learning in terms of the kinesthetic. And again, there might be some kids that are a bit stronger, a bit weak in these areas, but they all need to do it. They all should engage with it. And they do that about 4 or 5 times. Then I get them to unfold that bit of paper. And then what I show them is the distances from the sun in relative terms. And there is no better way to depict that than the A3 bit of paper. And if you have a look at the slide that's in front of you, Pluto is almost 40 centimeters away, if you like. Now, I know in science we talk about astronomical units. But again, with Year 7, with Year 8, do they really need to know that an astronomical unit is the equivalent of 150 million kilometers? No, they don't. And remember, the syllabus content area is talking about the relative distances. So what they then do, where they put that last point, if you like, on their bit of paper, they'll just write above it, Pluto. Now, what I said to them in the instruction is to fold it in half. Now, what you notice there, Uranus is 19.2, let's say centimeters. Now, when they folded their paper in half, It's obviously not at 19, but it's right in the middle at 20. But it's close enough. They don't need it to be absolutely accurate. And what I get them to do right in the center of that A4 strip of paper, they write Uranus. Now, what you'll notice halfway between Uranus and Pluto is 30 centimeters. That is exactly where Neptune is relatively in our solar system. And then they realize that those two or those three are equidistant. Now, what happens if you fold that half again? Well, you get about 10 centimeters. Now we're looking at the front part. That 10 centimeters from the sun is where Saturn is. If we half that bit of paper again, we're 5 centimeters from the start, that's where Jupiter is. Now, if I was to put it to you, before we started this exercise, where would you think Jupiter is on that continuum, on that A3 paper? I would bet the majority of you would have it either halfway or 3/4 of the way down your bit of paper. But it's actually very, very close to the sun. Now, when they half that again to 2.5 centimeters, they might look and say, hang on, that's not where Mars is. Can I say to you, 2.5 centimeters, relatively speaking, is where the asteroid belt is. Then when you half that 2.5 again, now again, it's not exactly 1.25, but that's where Mars is. Earth is 1 centimeter from the sun on that bit of paper.
You're going to have a hard time writing the word Earth there.
Absolutely. And if you ask your students, Pauline, at the start, on that bit of paper, can you mark where you think Earth is? I've never done this activity and had anybody mark it very, very close to the sun, 1 centimeter out from the sun. And then Venus is obviously, and Mercury, very, very close. But can I say at the end of the day, what are we trying to achieve? We want the students to have some sort of understanding. We want them to be able to model the relative positions or distances from the sun. This does it. And at the end of the day, you've got to look for those strategies that helps your kids, all kids. But that doesn't mean that this is the only thing we focus on. Pauline, can we go to the next page or the one after that, please? Thank you. And then there's opportunities where students will engage with their textbook. Now when they go back and read a little bit about Mars and the relative distance Mars is away from the sun and from the other planets, it's going to be a lot more meaningful. And again, we're not dismissing this. There's questions post the activity. We're not dismissing this because they've got to be able to read. They've got to be able to write. But at the same time, they've got to see it. They've got to engage with it.
You know, the funny thing is that I knew, right, that space was mostly a whole lot of nothing and space and stuff. But until you told me about that activity, it never really occurred to me just how empty it was.
Yep, absolutely. Absolutely. So again, multiple activities, multiple strategies. Look for those strategies that engage all students. And at the end of the day, look, it goes a long way to making our classes in terms of teaching and learning so much more powerful.